This is the folder I have created on the desktop. In the desktop, I have unzipped. So this is the file that we get. This is the zip file, that is cluster key. When I unzip this, I get two files. One is with extension .ppk and another is .pem. .ppk is made for the Windows, and if you are using the Linux platform, you can use the .pem file. Right after that, you have to download the PUTTY software, that is the exe file for the Windows is available at this path. And because I am using the Windows operating system, so I have downloaded the PUTTY for that. After that, how you will be configuring the PUTTY? So because I have already configured it, so that I'm able to give you the demo. So the configuration steps are given at this particular YouTube link, which are very simple and very easy. It's just a 1 or 2 minutes video that we will go through and see the steps. Right after configuring the PUTTY, what you have to do is we just have to double click. So you will be getting such kind of window. Since I have already configured, I can just load the already saved my Hadoop cluster, which I have named it as SME Hadoop. Since I have already done the configuration, I will load this and I am going to open this. Right. So now I have to log in. So for the login instruction, what will be your username? What will be your password? So once you have registered to this Hadoop starter kit, you get a confirmation mail. In that confirmation mail, you are provided this information. If you will check your mail, in the confirmation mail that you have received from the Hadoop in the real world, right? So you will be getting your host IP, your username, and password. So these are the three things that you receive in your mail ID. So this cluster key.zip file that we have already downloaded, and we have we are using it when we configure the PUTTY with the Windows or the Linux file. So I'm going to, so my user, I'm going to log in as the username which is provided to me. I cannot use any other. Four, three, zero. Yeah, R15. Right? So I am authenticated and now I can start working. So in order to work in the, so what we are supposed to do, we want to execute the MapReduce program using the big script. So what is the big script that we are going to execute over here? So that is being given over here in the form of a README file. So what I'm going to do is, see, this is the input location where my file is stored. So we have two files. One is you can say when we go when we want to do this particular program in this particular Hadoop in the real world environment. In their clusters, they have given us one stock price. The stock example that we have been doing, we want to find out the maximum stock price of the each of the stocks which are being listed over there. So since large number of companies are being listed over there and we have the number of records for the same company, so we have to find out the maximum stock price for that particular company. And for working on that particular example, so we have the input location where the file is being available. So the name of the file is maximum closing price, right? And where we are going to get the output, if you remember, we when we were working with Hadoop in the MapReduce environment, we had specified the output directory. So the output directory is already been specified over here. Then an important thing over here is the first task that we have to do is we have to delete the output directory. If the because it may be that I have already created a program, I have been doing the practice, and after that again I want to repeat the task. So if the this particular stocks directory it already exists, that means the output is already available. Your MapReduce task will fail and you won't be able to redo the things. So for just for the sake of that particular thing, that what we will do, if it is already there, we will delete it and then we want it to do the task again, right? So now let us start. So what do we do? So and our pig script is available in the max close price dot pig. We will be looking at the various, you can say the operators which are being used in the pig script. Now let us see what are the files available in this particular path. So we will write cd slash -dir w starter kit slash pig slash stocks. So in this particular path, yeah. So first we go to that particular path where the file is available, like right. So after that, using ls, let us see the list. So here you see we have two files over here. One is the max close price.pig and another is readme file. So this max close price.pig is the scripting file that we are going to use, right? So let us first see what is there in this script file. So in order to open the script file, what do? We are using the vi editor, and if we write the name of the file that we want to see the script. Now we have, see, this is the script file that is being opened in the editor, right? So first of all, what we are doing, load dataset with column names and data types. So in the yesterday's class, told you we have so many operators which we use for the different tasks. So the first operator that is over here that we have used for loading the data into the relation, right? So you can say this is a bag. Stock records is the name of the relation that we have specified. So we are using load. From where to load? User hirw input stocks. So here you can see in the readme file we have specified the user hirw input stocks where the file is available, right? Using pig storage. So which type of storage we are going, because we want to use the pig storage for loading the data. As these are the names of the, you can see the column names which are there. So we have exchange column, we have symbol, we have date, open, that is because it is about the stock. So open price, high price, low price, closing price, right? The volume, and then we have the adjacent close. So these are the various attributes which are there in the file. So what we are going to, so you can say these, all these attributes, using all these attributes, and we are specifying what is the data type of that, we are creating a schema for this particular relation. So the data will be stored over here in this way. After that, in the second step, what do? We group all the records by the symbols. So the group by symbol, this is just the name that is specified by the user. And then what we are using? We are using the group operator. Group stock underscore records. See what we have used, stock underscore records, because here we are storing all data in the relation only. We can call it as a bag also. We can call it as a relation. This is also called as table in the SQL, right? So what we are doing, we are grouping the table by symbol. So we simply have to write group stock underscore records by symbol. In the next step, see, we want to find out the maximum closing price for each of the companies which are there. So what we are writing is maximum closing. This is just a name to store the value. So for each, here you can see we are using for each. Group by symbol. Group by symbol is the data, now the relation is sorted, right? So it is grouped by symbol. Then generate, for each generate that we have started in the last class. Group max. Max is a function, the aggregate function that we are using. So what we are taking out from this, max stock underscore records from this particular relation, right? So this was the relation that we have created in the very beginning. Stock dot close. Close is what? Again, this is an attribute name. So what we are going to take the value. So from the closing price, so we can change this. If we want to take the high, so we can take the high. We want to take the maximum the opening price. We can modify the script accordingly by changing this column name we can say as max close. So how this will be represented as max close. And after that, what we are going to do, we are using the store. So where we are going to store, we are going to store the output and the output path we have specified using the pig storage, right? So we are going to store this data, the output that we have received. We say if we want to display the output on the screen, then we are going to use the dump operator. If we want to store the output into the file, then we are going to use the store operator. So now we have, see, this is the complete line of code, you can say, that we have written over here. So this complete line of code is, you can say, we have just used 4 to 5 lines, or you can say we have used only 4 operators in order to perform the same map reduce task that we had done using the Hadoop, right? So we can see from here itself the pig script has made it, you can say, simplified it too much, right? So now let us execute this, right? Now we are back. So from the VI editor, we are back to our shell. Now we are going to execute this, right? So we have seen what is there in the script. Now the next task is to execute this particular script, right? So first task that we have to do is we have to delete that, because we have just for the precautionary sake, because we don't know whether it is available or not, we are going to stop this. Sorry, we are going to delete this. And for deleting, what is the command? Hadoop, because output is stored in the Hadoop. Remember, fs rm r output slash fix slash created. Now let us execute the pig script file. For executing the pig script file, we simply have to write pig as we do in the programming. Like if we want to execute a Java file, we just write Java. First we compile using Java C compiler, then we write Java and we give the name of the class file. Similarly, over here we are going to give the name of the script file. Tries dot pig. So our pig script is getting executed. So we haven't created any of the jar files. We need not import anything, do nothing. Here you can see. So the map reduce layer, it is launching. So slowly it will start executing. See, here it is showing step by step. It will be executing it. It's showing here map reduce launcher 6% complete, 12%. 36. So it is showing the execution engine is working at a backend, right? So our page of backend Hadoop execution engine or map reuse layer, right? So now we can see over here that the map reuse layer has been working behind the big script engine, right? So after that, it is simply going to show us that successfully stored 836 records, where it has stored the number of records. This is the output number of records that we have received. So that means we can say that on an average in the file that we have been working upon, 836 company names were there, companies were registered, and for each company we have found out the maximum closing price. So that's why in the output, where the output in the HDFS, you can say the user, HR user, 1540, this is our login. As you remember, output pig stocks. This was the output path where the data has been stored. So the total number of records that have been written is 836, right? So here you can say Remember, Job DAG, I told you direct acyclic graph that you can see over here. So the direct acyclic graph, which shows the all the information, how the processing has been happening, how all the statements which are connected to each other, the complete diagram that you can say that the task was done, and we get the success. MapReduce launcher completed successfully. And let us see if this command works over here. So here you can say, where is that? 1 minute. I wanted to show you there was one path where you could see everything on the cloud. There was a address. There was one complete path where we could see the uh, in the cloud everything, the complete details of the task that we have executed. Yes, here it is. So in the Amazon AWS, let me see if it shows over here. Okay, 1 minute. Control C is not. Let me check if the control C is working. Yes. Let us see if we are able to connect to the Amazon Web Services, and we are able to see the details of the task that we have done. And by that time it opens, let us check the output directory where the output is being stored. So Hadoop fs output /pig /stocks. Yes. So if you remember, when we had to see, when we were executing the MapReduce code in the Hadoop environment directly, that time also our output was stored in some output path, and the name of the file which stored the, you can say, the where the name of the file in which the output was stored was saved, right? So the name of the file, every time we are processing some task in the Hadoop environment, so the name of file remains same, that is part r 5 times 0, right? So let us see what is the output. We have seen the number of records, the maximum Hadoop fs cat / pig / stocks. Part or so here you see the output. So this is the maximum closing price of each of the stocks, and here the number of records that we have seen, it has shown that this is equal to 836. So these are the 836 records that we have received as the output, and which are stored in this part R000 file, right? So you can see now that the same task of MapReduce, that was bit, you can say, difficult, right? Because we had to write the Java code, we had to import so many Java files, then create a Java environment. From there, we imported the jar file. We had to export that file into the cloudera, then import that particular file into the Hadoop environment, and do all kind of processing. And now by simply writing the 4 to 5 lines of code in the pig script, we are able to do the same task. So you can say we are able to save the time, as well as we are able to save the time, we are able to save the efforts of performing the same task. So you can say the pig script makes the data analytics task more easier as compared to the working in the direct Hadoop environment using the Java, or you can say the Hadoop streaming task, right? So using Java, Python, and all, right, directly writing those script, you can say the Java codes, you can say it simply replaces those codes. We can do the task of data analytics better way using the pig script.